Welcome to Web Handling. My name is Dave Roysam. I am super excited to continue a very popular series on great questions in web handling. In the previous two clips, I answered the question whether it is the web's and/or winder's fault. In this final clip, I will have a single surprise answer to general questions like this. I know your time is precious, so let's get started. This is a great question, as are all clips in this series. What makes a great question, you ask? First, web and winding defects of all types, and there are hundreds of common types, are usually in the top 3 causes of waste, delay, customer complaints in most plants. Second, web handling is essential economics in web-to-roll, roll-to-roll, and roll-to-sheet plants. Third, it is not so easy to give a short, simple answer, but I will try my best here. Finally, as any others in this series of questions, we have lots of customer-supplier finger-pointing, and this leads to confusion, frustration, and delay. So let's get started. This clip is the final in a short series, so it would be more meaningful to see the first two, if you have not already done so. So, now is the time you have all been waiting for. The simple answer to questions like this is, it's everyone's fault! I don't mean this to be polite or politically correct or to be fair and balanced. It is literally true for many, if not most, defects, as we will see in the next half dozen illustrative examples. It can be difficult, sometimes dauntingly difficult, to keep personalities and politics and finger-pointing out of problem solving. One way I've found that helps is to focus on the facts and the physics first. More specifically, find out what are the influential factors suggested by the physics of the problem. These are often quite easy to list if you consult one of the many sources on common defects, such as the Roll and Web Defect Encyclopedia. Or, as I often have to do when I am called into multi-party disputes, is to treat the web as my customer, no matter who called me in and no matter who is paying my bill. Let us begin with the most common defect, the baggy lane. I have written countless publications on this subject, including a 24-clip series, Web201.45a through R. There are many others that you can study on your own. The major physics are a web chosen by the product developers and customer that is easily yielded, plus a web profile that builds up as the roll is wound and is made worse by winding tightness. As you can see, everyone from the product process developer to the customer and everyone in between is at fault, in the sense that troubles were a direct result of the choices that were made. Since blocking and bulk loss are also tight defects, just as baggy webs are, it should be no surprise to find out that nearly every factor is either precisely the same or quite similar. As you can see, everyone from the product process developer to the customer and everyone in between is at fault, in the sense that troubles were a direct result of the choices that were made. There are at least 3 totally different types of core crush, but we will focus on the one most common one here. You can learn more about this and other common defects in my award-winning and trademarked Web101 school. Since type 1 core crush is also a tight defect like the previous 3, it should not be a surprise to find that nearly every factor is precisely the same or quite similar. As you can see, everyone from the product process developer to the customer and everyone in between is at fault, in the sense that troubles were a direct result of the choices that were made. Okay, now let's do something quite different than a tight defect. There are at least 3 totally different types of curl. One comes from asymmetric manufacturing and another comes from asymmetric converting, such as laminating. Here, we will focus on roll set curl. The major factors here are defined by the physics and are mostly product process design choices related to geometry, such as web thickness and core diameter. Winding tightness has only a very, very tiny influence with this defect, so it is probably a distraction to even list it here. As you can see, everyone from the product process developer to the customer and everyone in between is at fault, in the sense that troubles were a direct result of the choices that were made. Okay, again, let's do another totally different type of defect. There are at least 5 totally different types of telescoping. We will deal with the 2 most common ones here. If you don't know how to tell one telescope from another, I would suggest you literally go to school. The major factors for type 1A and 1B are defined by the physics and are mostly product design choices related to web coefficient of friction properties and geometries such as core and roll diameter. In this case, however, winding tightness, or more specifically tapered tension, is as strong as the other factors and thus deserves strong attention. As you can see, everyone from the product process developer to the customer and everyone in between is at fault, in the sense that troubles were a direct result of the choices that were made. So, getting started with defects is actually quite easy, especially if you could stay away from politics and finger pointing. First, you need to do your homework on the major case and subcase of the specific defect you are working on. As I've said hundreds of times before, a wrinkle is not a wrinkle is not a wrinkle. There are about 20 different kinds, each with their own remedy list. As seen in this clip, there are 3 totally different types of core crush, 3 totally different types of curl, and a half-dozen telescopes. The second step is also usually quite easy. That is to list the major factors suggested by the mechanics of the physics of that very specific defect that you're working on. This is usually quite easy, as publications cover most of the defects you will ever work on. The third step is slightly more difficult, and that requires a deeper understanding of the specific defect and the environment in which those defects occurs. Some factors, such as adjusting winder TNT settings, tend to be easier and thus would be a place to begin. However, it could be totally naive to think that you can make all your problems go away by merely playing with the winder knobs and the winder curves and the winder taper. Sometimes, as we saw in Roll Set Curl, the winder has almost no roll whatsoever. More often, the winder can influence frequency and severity a little bit, but may not have the authority or the power to remedy the problem well enough to everyone's satisfaction. Then we may be forced to consider even stronger factors which involve product process design or manufacturing profile. Finally, pick a remedy option or options using any of the economics-based techniques and then just do it. If you use the free Roysum Library search tool by Abbott App, you will find over 1,000 articles, columns, papers, theses, and other publications on defects. You will also find 10 books, including 2 must-have references, the first being a defect encyclopedia and the second being a winding textbook. However, let me suggest that a far faster way may be to take my award-winning and trademarked Web101 training that has been taken by 5,000 students from operators to PhDs. In 2 or 3 days, you will learn nearly everything you will ever need to know about web and winding defects. Thank you so very much for allowing me to share my thoughts on great questions in web handling. If you have a defect or other topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.